Okay, so this next problem, a your turn question, I'll start you guys off and then I'll have you finish the rest on your own. Says the typical amount of sleep per night for a college student follows a normal distribution with a mean of 7 hours and a standard deviation of 1.7 hours. Given the data above, draw a normal curve associated with this. So the first thing, whenever we draw a normal curve, because you'll be asked this a couple times in your homework, make sure you draw the mean and draw 3 standard deviations out on both sides, both 3 standard deviations below and 3 standard deviations above. Also, for extra practice, it's always great to label the percentages so we get used to those. So our measure of center, which is our mean, is going to go right. So sketch yourself a curve. And our measure of center is going to go right down the middle of it. Then, I'm going to go over this a little bit. We are going to write in the values for 3 standard deviations below the mean, as well as 3 standard deviations above the mean. So to determine 3 standard deviations below the mean, I start with my mean and I subtract the value of the standard deviation, which is 1.7. So 7 minus 1.7 gives me 5.3. That's the value for 1 standard deviation below the mean. To get the value for 2 standard deviations below the mean, I'm going to subtract another 1.7 to get 3.6. To figure out 3 standard deviations below the mean, I'm going to subtract 1.7 again, and I get 1.9. Now we're going to label 3 standard deviations above the mean. So I start with my mean. The value for 1 standard deviation above the mean is going to be 7 plus 1 standard deviation, which is 1.7. So then I get 8.7. Then I'm going to add 1.7 again to get 2 standard deviations above the mean for 10.4. Finally, I'm going to add 1.7 again to get the value for 3 standard deviations above the mean, which is 12.1. So now take a minute and go ahead and pause the video and label the percentages and try and answer these 3 questions. Okay, go ahead and check your answers. Make sure you wrote in the correct percentages, along with check your answers to parts B, C, and D in the your turn. Okay, last question. It says, suppose a baseball player is a 300 hitter. What does that mean? That means their ability to get a hit anytime they go up to bat is 30%. The distribution right over here shows the results of 5,000 trials in the simulation. So it shows all the possible performances that could happen by random chance to this hitter, given the fact that they really are a 300 hitter, or that they really do get a hit in 30% of their at-bats. So it says, explain why it is reasonable to use the 68, 95, 99.7 rule when working with the results of the simulation. So take a look at the shape of the graph. Why can I use that 68, 95, 99.7 rule? Well, because the graph is approximately normal, or it's symmetrical, bell-shaped, however you want to word it, but it has this approximately normal shape. Letter B, explain the mean of the distribution. Or I'm sorry, estimate the mean of the distribution and explain your reasoning. Well, remember, mean is your measure of center. So look here, you might need to zoom in or look closer at your paper. And, I'm going to zoom in just a minute. Go ahead, look at the center of the graph, because mean is a measure of center. Estimate the mean. So I would say the mean is about 0.3 or 30%. However you write it is fine. couple of reasons why you can give that, why you think that's the mean. One is it's the center of the graph. Second reasoning, well, remember the 68, 95, 99.7 rule. And we said we can use this rule when we're working, oh, I'm sorry, I was getting ahead of myself, letter C. Sorry, a second reasoning, you guys, would be right up here, what we highlighted. I'm not surprised because their ability is 30%. And so that would be the center of the distribution. Okay, letter C, estimate the standard deviation of the distribution. So we estimated standard deviation back in chapter 7. So let's take a look. Remember, when we estimate the standard deviation, the first thing we want to do is estimate our mean. And we said above that our mean is estimated to be around 0.3. Okay. Now, where do I think the standard deviation is? Maybe I think it's 0.05 because that's the increments that the graph is going by. Well, let's take a look. If it is 0.05 and I go out 2 standard deviations below and 2 standard deviations above, that takes me from 0.2 to 0.4. That would be my interval for 2 standard deviations. Now, in letter A, we said we can use the 68, 95, 99.7 rule because the graph appears to have approximately normal shape. And remember what the rule says about 2 standard deviations. If you're 2 standard deviations away from the mean, it should contain about 95% of the data. Does it look like 95% of the data is inside that interval there? It does. So I'm going to estimate the standard deviation to be about 0.05. And why did I pick that? Because 95% of the data is in the interval or is between 0.2 to 0.4. And that would be 2 standard deviations below and 2 standard deviations above if the standard deviation is really 0.05. Okay? And I believe in part 1 of the video notes, you already addressed the important note at the bottom.